Welcome back to my channel Conquer the Fear. I am grateful that you have loved my part 1 video where I have explained the tricky Java programs along with the solution. Now, as I mentioned, 90% of the developers are not aware of this particular concepts and also the solution to it. So that is the reason I had made the part 1 and the people have loved it. Now I'm going to make the part 2, which is going to be an extension of that, where I will be still explaining those particular problems and what are the tricky solution to it. So wait and watch till the end. Now let's jump into the very first code. So here we are going to discuss about the break, continue and the return in a loop. So when you are trying to write this particular statements, the break, continue and the return, many of them are not aware what would be the output or what would when exactly the how the code flow work will go and flow. Many developers are not aware how the flow works and what happens when there is a break, continue, or a return. They get confused, and also when they get a problem with any of this particular initial level of Java coding test where they need to identify the guess output program. So they actually wrongly answered that particular question. So in this I'm trying to explain you that same thing. Now, if you take a look at this, how the particular public static void main is written over here. Now, if you take a look at this, now here we are taking an example of break over here. Now, if you see the for loop, whatever we have written, inside that we are trying to write an if loop over here. So this is one level of for loop, and then there is a if loop over written here. Now, when we try to write a break statement, so this is going to exit the entire for loop over here. Okay, so if the matching is 2, then it is going to print that and then it is going to run it. So the innermost loop or the switch statement will immediately stop that. Now you see the output would be 0 to 1. Now to make sure to write this particular code or to print this, I have written this particular print over here. Now you see this will be printing 0 and 1 over here. Let's try to run this particular example. Now if you take a look at this, this has got 0 and 1. Now let's say if I change it to 3, again it will be printing 0, 1 and 2, and then it will be printing like that. So this is how the break statement. Now because most of them get confused there, that they will think that this if loop will be breaking up because there is no while loop over here or some for loop over here. This will immediately stop that particular flow. Now let's jump into the other code flow, that is the continue part. Now we have another for loop written over here. Now the same case is with what we have written here, actually similar the case where I've written a for loop and outside that I have another loop. Now if you take a look at this, when you call continue over here, then if this particular condition is satisfying, so this will not work ahead, or the it will not proceed with the next set of questions over here or the next set of statement. So the rest of the code will be skipped over here. So whatever the current situation it is there, the variables and everything will keep it as it is, and then it will go to the next iteration. Now in this case, what will be the iteration? If you see here, it is going to be 5 over here. Now it is iteration is going to 2, right? So if you see it is going to print that, or it is going to skip that particular thing. Now if you see, the condition is 2 over here, so it is going to skip that particular 2 and it is not going to print that. So you will see here, just run and see this. Now if you see, it is only printing till 0, 1, and there is no 2 over here, 3 and 4 over here. So that is the reason it is stopping over there. Let's say if I'm trying to update here with this and try to run this again, you'll see. Now you see here, it is 4 is not printed over here. So that's how it works. Now at the end, if you see, at the end of this particular code, I have written one return example over here. So basically, whenever you are trying to return something without any value or something, then it will return that particular method very early only. So if you take a look at this, I have written example written over here, I have written one method over here. Now if you take a look again, there is a statement written over here. Now you see the return statement is written. So for similar use cases, I have made use of the return statement over here. Now if you take, if the method will exit here only, the current method will not flow further, then it will return back. So it will return from here itself. Now if you take a look at this, it is going to, once it is 0 1, and the moment it actually encounters the 2, it is going to return that. Now it is going to return that, and it is going to print that particular thing. Now if you take a look at this over here, if you see, this is a written example, so which is one which is getting the calling over here. And then if you see the when method is called over here, now inside this it is going to return, there is not a single thing printing over here. Now let's say if I move this particular statement over here and try to run this again, so that will print over here. If you see, it has printed something over here to back in the main after the return example, and then it has returned it. So that is the reason. So it has properly flown when, and there is a variation when it comes to when you deal with this break and other methods, other keywords which I've used. So I hope I was able to explain you properly. Let's take an example of the second one. The one which we are going to discuss about is the type inference with generics. So when you are dealing with generics, we are going to make use of the type reference, where there was a diamond operator introduced in the Java 7, which has actually simplified your generic types declaration. So whenever you are trying to, let's say, earlier prior to this particular Java 7, what you used to do, you used to write a list, and then the generic type, that is going to be the string of that particular name, and then I have to write the array list, and then I have to write this particular diamond, similar this particular string, I have to write it. So this was very much redundant, as I have already declared this as a string. It was again, it used to, we need to add this particular compulsion to write this. But when it comes to Java 8, this has been removed, and this is going to be the implicit one actually. So it is going to be the type which is going to be on the left side. So it will be inferred from the type which is declared using the list. So that's the difference, because diamond operator, where the compiler will going to infer the type of the generics, which is going to be the constructor. So it is going to reduce your boilerplate code. So this was part of the Java 7, but it is going to be much more efficient when it comes to the functional programming as well. So this is how the changes with respect to the diamond operator. Now let's look at the third problem. Now we are going to look at the null pointer exception with an auto boxing. Now if you are aware of that auto boxing and unboxing, we are trying to convert from an, when it is called as an auto boxing, when you're trying to convert from an primitive type to an integer type, or integer type to the primitive type. In that case, we are going to use the auto boxing and unboxing over here. Now, if you see, this is going to be a null pointer exception when you're trying to unbox or auto boxing it. Now, the reason why, because I'm trying to write here, if you see, an integer with null value over here, and then I'm trying to assign an int j is equal to an I, so which is a null part over here. Now, if you see, this is a primitive type and this is an integer type. Now, when you're trying to do the auto boxing over here, now in case of, like, if it was something as a numeric thing, some value, it could have automatically taken care of that particular part if you have directly written in the reverse case. But in this case, if you see, it is throwing a null pointer exception over here, and then ultimately it will print this particular value. So let's take another example. Let's say if we have boolean over here, and then we are trying to assign a value boolean, and then if you are trying to check if it is this particular value is then that, because it is not going to infer the true and false over here. So that is going to, this is not going to print, or not go under this, and there is a null pointer exception over here. So that's how it is going to break that particular scenario. Now when you're trying the integer objects with null as a value, and you try to unbox it to the primitive value, then there is going to be always a null pointer exception. Make sure you answer this particular question very clearly. So if an interviewer asks you and give you a situation that is trying to assign that particular value, then they're going to give an null pointer exception. You can clearly explain. Now same is going to be applied for the boolean as we already discussed. So this is one of the bug actually. So that's how we are going to and that is a problem with this particular when you're dealing with the null pointer boxing and unboxing. Now let's take another example. Now if you take a look, this is going to be the big decimal, and if you want the precisions like floating point arithmetic things, then in that case big decimal is a solution. Earlier we used to use the float or long and other doubles like that, but this floating specific numbers which we call float or double are not very precise for the exact decimal calculation which we want when it comes to the calculation. Now there is a problem with this, and hence the bit decimal came in to save this particular problem to solve this, and this was introduced as part of the Java 8 and the latest features. Now, if you take a look at this, if you see in the main method there is a result, and I'm trying to add some double number with another double number over here. Then if you see the result is double over here, but ultimately if you see the output is here is there something like this. If you see, let me run this and show you. Now if you see, this is not something what we are precisely looking out for, but if you see when it comes to precise this one over here, and we try to add this bit decimal dot, so there is a way to add this, subtract this or minus something like that, and then we can use this. So if you see, this is going to be exactly what exactly it is going to be. So it is going to be zero point 0.3 over here, which is going to be the precise over here. Now, when you are doing the binary floating point representation, that cannot be perfectly represented in all the decimal fraction. So that is going to lead some precision issues over here. So when you're doing some financial calculation or where your application is dealing with this particular calculation, then you need the exact decimal with the precise thing is required. So big decimal is used over there, and it is going to represent your number as a particular string type. So there is no binary approximation errors happening over here. So that is the solution when you are dealing with the precision number, and the big decimal is the solution for it. Now we are talking about then immutable collection over here. Now we are talking about pre-Java, pre-9 and post-9 over here. So we are going to take an example of that where we had this particular immutability collections created very easily. So we will see, like, what is the previous or the pre-Java 8 way to create the immutable list over here, and then we'll also look what are the different ways to create with using the latest Java versions. So if you take a look at this, which is prior to Java 8 over here, you see this is with the way where you used to create it, and then this was the mutable list over here. But let's say if I wanted to create an immutable list, then unmodified list was an way to create that particular unmodified list. Now if you want to just check out, like, how it is unmodifiable, you can actually try to add this particular element after this has been created as an unmodified list. Now this will throw an unsupported exception over here. So if you want, I can run it and show it to you. But when I try to run this particular mutable list, it can still modify, that is going to be affected on the immutable list. Let me try to run this and show you. Now if you take a look at this, uh, when I try to add this, there is going to be a modification over here, and it is going to throw an unsupportable exception over here. So this is when actually I'm trying to modify this. But when I'm trying to add the mutable list over here, where I'm trying to add something in this, then it is going to clearly add that inside this. Now this is going to implicitly refer to that particular list, right? So that is the reason, because I have created on top of that, so hence it is going to make that particular changes mutable over here, and hence it is going to reflect that particular changes. So now this is going to be still a tricky thing, because we are trying to create an immutable objects which was little bit cumbersome, and it was still exposed of underlying mutable collections over here. So there was a loophole over here. Now let's try to look at that particular with the solution. Now if you take a look at this, this is the solution which is good when you're dealing with Java 8 and 9. So there was a convenient factory methods which were introduced for creating the immutable collections over here. Now let's take a look. We already discussed there was, let's say, a list of immutable I wanted to create for a list. Now in that case, if you see, this is one of the list of method which is an immutable way of creating. So still, if you see, this is an immutable way collection of creating it. And then let's say if you are trying to create, this is again going to throw a modification exception over here. Let's say we are trying to do some immutable set over here. Again, if you see, there is an immutable set. So similar to this, there is an immutable for the collection for the list. Actually, there is a set as well. Similar is going to happen with the map as well, where I have created the key and the value pair, key and the value pair, like that. So in that case, you can add, the way actually I'm trying to add it over here and deal it with. So when you're dealing with list of methods, list set of method, and this one, they are going to give you a concise way to create the immutable collection. So that will not, that will, I mean, whenever try to add something inside it, then it is going to throw an unsupported operated expression. So that is the benefit of it. So any modification to you do that, it will throw an exception. So it will not retain the references to the original mutable sources if it is created from the one which is already created, like in the case of one we did in the earlier example. So it will not be referenced over there. So that's the basic difference over here. Let's take an example of an hash code and equals contract. So if you are aware of the basics of Java and object class, you will be must be aware that you need to override the equals and hash code, and what is the significance or the importance if we don't override this. So what is the impact on the class when you are trying to override one of them and you're not trying to override the another one. So there is a correlation with this too. So if you are trying to violate this particular principle, where you're not trying to override, or are trying to override only one of them, then it is going to be an unpredictable behavior, and the hashing based collection will not work as properly. So basically, when you're trying to store some element into an hash map or an hash set, hashing algorithm comes in picture. It will try to identify the key, and then it will calculate the hash code, and then it will store that particular message in that particular collection. Now if you take a look at this, I have a person class over here. I have the variable names, attribute name and age over here. But if you take a look at this, I have only overridden the hash code or equals method over here, but I have not taken the hash code over here. So I have not implemented this particular hash code. So what will happen, it is, if this particular hash code is not generated or overwritten, so the default object hash code will be used for this particular hash code calculation, now which is going to generate a different hash code from one what is intended for this particular person class. Now in when you try to compare these two things, then it is certainly it will be different object. Even if you try to compare it with the, now even if you compare with it is going to return true with the equals, but in this case, if it is, you will see those are totally two different objects. Now let's try to give you an example over here. Now I will have a map over here. I'm trying to add this. If you see, the exact content is same over here. Now when you try to refer to this particular content with equals, now this is going to be true. But when you try to put p1 2 is equal to value is equal to true, and you're trying to compare it with this one, now this one will check it that it is going to have a value or not, and then it will check that. So this is going to return true over here. So this is going to, let me try to run this first and show you. Now if you take a look at this, this is going to be the equal things when it comes to comparing it with. Okay, but when you try to put that particular element, is you want to check it, it is going to return true over here. Now this is will be likely true, I mean return false if the hash code is not overridden over here. So in that case, if you see, this is going to, if you see that this is going to be a false over here, which is going to be contains key. Now when you're trying to see the p2 over here, it is trying to check if it is containing or not, because it is going to refer to the different object over here. Now when you try to get it the p2 also, it will not find only, because this is not going to get that particular object. But let's say if you are trying to override this, or you try to uncomment this and try to run this. Let me try to import this class over here for you. Now when I try to run this, just see the output what exactly it is. Now if you see earlier it was referencing as false, but here if you see it, after I implemented that particular hash code, it is going to be the same case, that it is going to return true. Now let's check it out. If I try to comment the hash code equals over here, so what will happen here? Well, let's try to see. Now in this case again it is going to be the false over here. It is not going to match it in this case, and then it is going to return null over here. But when you are trying to do something like that, then this you see it will return true. And also if you see it, then earlier it was returning null value over here, but here it is returning the value over here. So that is the difference. When you're dealing with equals and hash code, you should always try to have this particular implementation for your custom class you have written, so that you uniquely identify that hash codes and the equals mechanism when you're trying to deal with that particular object. Now here we are going to discuss about the default methods which were introduced as part of the Java 8 collection features. Now prior to this, when there was an interface and if you have introduced only some methods or a constant, then it used to break all the implementation which were had this particular interface implemented. So this were actually, let's say, I just give you an example. Let's say I had an interface over here and I defined the legacy class over here shape, and then I had already one method over here. But if you try to add one more method like this, get parameter, and prior to this, before adding this, let's say you had this particular class implemented by somebody, and then you try to implement it, then in that case the implementation class would go on a compilation error. It will ask for a method to be overridden or method to be implemented, which is not overridden if you try to add this. So at the compile time your application will not compile, and it will cause your application to shut it. Okay, so in that case you need to implement that particular thing in order to cause avoid the compilation error over here. So that's where default methods were come in picture, where it saved your compatibility when you try to introduce some features or a methods functionality where it is applicable over your throughout your implementation. And also it will not break your functionality. So let's try to take a look at this. So let's say if I'm trying to create a new method or interface, if you see the default thing, so now interfaces will have a default method implementation, so it will not break your existing implementation. Let's say I have a new shape. Now this one, earlier let's say it was written like this. Now let's say you have introduced some default method to do some calculation. So this is one of the implementation where you're give the given the implementation itself in the interface, and it is not like the case where you have given abstract method over here, but you're trying to give the exact implementation of that particular method. So hence your implementation is written over here, so hence the class implementing would not require it to implement those, and there will be no enforcement like earlier it used to happen. So this was a broader change done at it. Now default method is going to allow adding new methods to the interface, so it will not break your hierarchy or implementation trees. So this has a very backward compatibility feature. Now when you enable this particular with an evolution like this, then you can have this static method also, which were introduced along with this along the Java 8 features. So it is going to allow you directly use of this particular method utility in your interface over there. Now you see this, there is an implementation where you can actually call this. No need to override this particular default implementation method. You can write your own implementation. There is no need to. Similar is the case with this, where you doesn't need to override that particular thing. Now if you see the implementation, when I'm trying to call this as a circle thing, I get an call. So here the overridden method is called over here. And if you take a look at this, this is going to be the default method, which is you can override it or you cannot override it. That's upon dependent on you. But yeah, this is one which is the default method we have introduced over here. So this is similarly to the case of square as well, and this will call that particular static method over here. So that's the change with respect to Java 8, and it is one of the handy solution when it comes to without breaking your internal hierarchy. Now let's try to discuss about the lambda expressions and the functional interfaces. Now if you take a look at this, there is going to be an anonymous inner class where earlier prior to Java 8 we used to write this particular anonymous inner class like this, and you write the functionality over here. So you need to explicitly write this, and this was one of the boilerplate code, unnecessary, unreadable, and also it was not quite efficient when it comes to using this. But when it comes to lambda expression and the functional interface, this was a big change. We'll look into it. But if you see, this anomaly class is used for single method interfaces which we want the implementation to be done. Let's look at the post lambda implementation. Now what has happened changed. Now when you're dealing with interfaces, that two functional interfaces, you have a very concise way to write it. You have a very method references which we can be used to call those particular thing. Now let's look at this. When you try to see at the lambda expression over here, now you see the earlier code what we had written. Now in similar way you can make it use of the lambda expression and achieve the same functionality what we had seen, which we have written inside this particular method. So instead of writing that in the boilerplate code, you can simply infer this and write this as a lambda expression over here, and then still it will function like that as well. Now when you're dealing with predicates, let's say the functional interfaces, now we can make use of the functionality over here. Like you have defined the predicate, you define the logic over here, and then you can use it in the even. Like there is an even. If you see here the predicate, I'm trying to test it whether it is coming as 4 or not or something like that. It will check it out. Okay, so that's what it is, the output. When we are dealing with the consumer, let's say you're doing some for each for each of them. Let's say you have the array list of this and you're trying to do the for each. You can actually use the consumer which will print that particular hello where, and then we can make use of the method reference also, which is going to be similar to the sysout or similar to the println method when you're trying to call it directly with the static reference. In that case we can make use of. So with Java 8 lambda expression coming in picture, it is going to give you a concise way to write the implementation of the functional interfaces, that too a single abstract method. Now this is one of the great readability when you are trying to implement the callbacks method. So method references are even shorter now as per the syntax with respect to the lambda expression. So you can use in any of the existing methods. So this has got quite beneficial when you are trying to deal with the collections and the concurrency over here. Now let's try to look at the Java Stream API. There are some intermediate operation, the terminal operations. Now prior to this particular Java 8 feature, we used to manually try to filter. I write our own logic and used to transform that logic. The way we used to do earlier is like when you used to do, let's say you have an array list, you're trying to add certain number in the for loop over here. Let's say you want to do some square of that particular thing, you write your own logic over here and try to add this in this particular number over here. So this integer you're trying to add it over here. So this is the way how you used to achieve it prior to Java 8. But after Java 8 streams has been introduced, there is an easier way to do it. So there are some lazy operations which are given, like terminal and the intermediate operation when it comes to Java. So these are only executed only when the terminal operations are greater. Let's say you are doing some intermediate operation, it will not be executed until it is calling the terminal operation. Now let's look at the example. Let's say you want to filter out something for let's say for some condition. So in that case you can write the intermediate operation which will not be called up, which will be a lazy, where it will only return the stream over here, and then it will only trigger the final output when you're trying to do the terminal operations over here. Let's say you're doing some collect or you're trying to do for each or something else like that. So if you take a look at this, I'm converted this number, the array list, into the string, and then I'm trying to filter it out with some condition that is going to return this. Now this will only collect the which will be part of that particular condition, and then once it is going to have that condition, it is going to return to that particular filtered element over here, and ultimately it is going to collect as a list over here. Now with this particular Java 8 being Streams API, it is one of the very best way to process your collections when you're trying to work it in a declarative way. So intermediate operations are there. You have n number of operations like filter is there, map is there, sorted map is there, distinct, etc. Now these are lazy operations. They won't be called until your data is called in a pipeline and with the terminal operations. So it will not process the data immediately. Rather, it is going to build some pipeline over there. Now, when you're calling the terminal operation, let's say for each, collect, reduce, count, sum, minimum, max, first, or whatever, like the terminal operations, this is going to trigger the actual execution of the streamline operation, and it is ultimately give you the result for or a side effect. I mean, it's going to give you a result, or it is going to produce something. So this is going to be the lazy initialization, which is one of the important when it comes to doing your intermediate operations, and if you're dealing with terminal operation, it is going to produce that result. So that's how when it comes to stream API, it works in like a charm over here. Now these are quite important when it comes to the optional. Now prior to Java 8, we used to get the null pointer exception because we are trying to handle it in a very inefficient way. Let's say you had some user and you wanted to call it with this particular user is equal is not equal to null. Every time you used to check this particular condition, and this was one of the boilerplate code and inefficient way to deal with. So we used to every time call this check, and every time it like this. So this is one of the non I would say efficient way to write the code. Java has come up with a precise way to deal with it. Now if you I mean, in this particular example itself, let's say you had an optional created, and you try to access, I mean, with this particular app, you're trying to create a new address, or you're trying to assign it some value as a null over here. Then this is going to throw a null pointer exception. And also, if you see, it is going to compare that particular app is good with the user one, which is going to assign a null value over here. So this is how you used to have that. But let's see how it has been addressed in the optional it. Now in this class, you're going to replace your every null check with a more expressive and a better null safe approach over here. Now if you see, in this you're trying to check it over here. Let's say in the main method, if you see, if I'm trying to create an app, okay, and then you're trying to create a new of this particular thing, it will have the null addresses here still, like it will have some checks over here. But if you see the get user, there is a better way to handle it. It is going to wrap it in an optional, whether if it is nullable. So it is going to handle your null use case over here. Also, if a user is present, you can actually check if the address is present or not, and you can wrap it in the optional as well. Now, similar is the case with the off nullable as well. There are different. You can also create it with the optional of using that particular thing as well, and then ultimately you can print. So there is also a utility method where you actually can check, like you can have optional and check if there is something else. If it is the default value, you need to provide if there is a some discrepancy when it comes to an output. So this is how you deal with it, and you try to get this. Let me try to run this and show you. Now you see, this is going to be the unknown over here, the very first thing. This is going to be the oak, and then it is going to again ultimately have this null. So that is the reason. So it will have that particular value as an blank null over here. So if you see here, this is going to take an address as a null over here, hence it is going to return null unknown over here. But here if you see, it is taking some address as a new over here. So there is something which is going to we are passing, hence it is going to return that particular oak over here. But here in this case, again I'm passing null over here, but it is not going to return a value over here. So that's the reason it is behaving in this way. I hope I was able to explain you properly all the examples and all the scenarios when you're trying to deal with a tricky Java interview questions. So, if this video was helpful, please share it with the needy people. Also, don't forget to like, subscribe, and hit the bell icon. Thank you for watching the video.